Good morning, everyone. Today's title is through the course name, it is Optimization Techniques, and today's title is Network Models. Actually, through the network model, we are going to take up some basic concepts for this programming, evaluation, and review techniques and critical path methods. So, I am Dr. S. Velmurugan, Assistant Professor 3, Department of Mathematics under the School of Science and Arts, Science and Humanities. So today we are going to take up the basic concepts of this project management. So here there is a content. So the first content is based on the project management and scheduling. So through the project management, we have some concepts, that is PERT and CPM. The PERT means it's a project revolution, project evaluation and review techniques, and CPM means it is a critical path method. And based on the project management and scheduling, we are going to see some introductions. The introduction means if we are going to start a new project, so before the project, we have to create a unique product or services. It is a specific and timely, usually multidisciplinary and always conflict ridden. So this type of projects, we have to use this particular model. So in the projects are a part of an overall program and are broken down into the well-defined task. It likes jobs, because we have so many tasks in the particular projects. So we have to separate into different tasks, and through the task we have a subtasks. So the subtask and further if desired, all of which must be completed within a specified time along with a minimum cost. So this is what the exact procedure for this PERT and CPM has done. And there are some examples I am just giving here. The construction of a bridge and a highway, power plant, repair and maintenance of an oil refinery or an airplane, design development and marketing of a new product, and research and development work, etc. These are all the some examples I am giving. So as per your area, you have to take up this particular network model. So such projects involve a large number of interrelated activities or specific tasks that must be completed in a specified sequence or an order, because in mathematically we have say in a sequence that will be make it as order, and requires resources such as personnel. And the objective of this project management, so if you are starting before the project, is to schedule the required activities in an efficient manner, so as to complete it on or before a specified time limit and a minimum cost of its completion. So any project, it is necessary to prepare a plan for scheduling and controlling the various activities like tasks. So because the various activities has been taking through the particular task, so involved in the given project, the techniques of operations and the research used for planning, scheduling and controlling large and complex projects are often referred to a network analysis and network planning or network planning and scheduling techniques. So these are all the implementations we are going to use it. So these techniques are based on the representation of the project as a network of activities. A network is a graphical plan consisting of a certain configuration of arrows and nodes for showing the logical sequence of various activities to be performed to achieve the project objectives. So here the PERT and CPM are two methods where was developed in 1956 and 58 by a researcher team to help in the planning and scheduling of the US Navy Polaris nuclear submarine missile project. So which is involved in the thousands of activities. The objective of the team was to efficiently plan and develop the Polaris missile system. Since 1958, this technique has proved to be useful for all jobs or projects that have an element of an uncertainty in the estimation of durations. As is the case with new types of projects, the likes of which have never been taken up before. So the critical path method was developed by DuPont company along with Remington Rand Corporation. The aim behind its development was to provide a technique for the control of the maintenance of companies' chemical plants. In course of time, the uses of this critical path method was extended to the field of cost and resource allocations. So actually PERT and CPM, because PERT is also used for minimizing the cost and CPM has to minimize the time duration. So these are all two techniques has been used. So the difference, there are some basic differences are there. So that is what here I am giving here the PERT and CPM, the basic difference, and the basis I have given the first column, and the PERT I have in the second column, and the CPM through the third column. In the first column, the basis stands for the PERT. PERT means it is a program evaluation and review technique, but the CPM means it is a critical path method. And the model, the PERT model, it is a probabilistic model under which the result estimated in a manner of probability. But the CPM, it is a deterministic model under which the results is in ascertained in a manner of certainty, but the PERT is uncertainty. So that is what CPM has been put it as in the certainty. So and the time for PERT, it deals with the activities of uncertain time, and it deals with the, I mean the CPM deals with the activities of precise of well known time. So that is what already I have said, this is certainty and the PERT is uncertainty. And the orientation of the PERT, it is activity oriented in as much as its result is calculated on the basis of the activities. But in the CPM, it is event oriented in as much as its results are calculated on the basis of the events. But the dummy activities have been taken place for this PERT and CPM. For the PERT, it does not make use of dummy activities, and the CPM, it makes use of dummy activities to represent the proper sequencing of the activities. And the cost of the PERT, it has nothing to do with the cost of your project, but in the CPM, it deals with the cost of your project, schedules and their minimization. And specifically for the estimation of the PERT, it finds out the expected time of each activity on the basis of three types of estimates. But in the CPM, its calculations based on the one type of time estimation that is precisely known, and time for the PERT is restricted to time variable, but time is for the CPM includes time cost trade-off. So these are all the difference, main difference, but some of the difference will be there. There are no essential differences between PERT and CPM as such. Both of them share in common the determination of a critical path and are based on the network representation of activities and their scheduling that determines the most critical activities to be controlled so as to meet the completion date of the project. So however, the following are some of the other major differences are there. So in the PERT, three estimates are used to form a weighted averages of the expected completion time of each activity based on the probability distribution of completion times. But the second thing is, it is basically a tool for planning and control of time. And the third one is to perform a PERT analysis on a project. The emphasis on the completion of a task rather than the activities required to be performed to reach a particular event or task. It is also called an event orientation technique, already we were discussed in the table. The fourth point is it is used to used for one-time projects that involved activities for non-repetitive nature. that is activities that may never have been performed before, in which time estimates are uncertain, such as redesigning an assembly line or installing of a new information system. The fifth point is for the PERT, it helps in identifying critical areas in a project so that necessary adjustments can be made to meet the scheduled completion date of the project. And specifically for the critical path method, we have a difference. In CPM, there is only one estimate of completion time of each activity. This technique was developed in connection with the construction and maintenance project, in which the duration of each activity was known with certainty. So, I am just giving an example here. There are a lot of branches now, students who have studied. Suppose, for example, if it is a civil engineering, if it is a mechanical engineering, if it is the computer science engineering. So, in their own branches, they have a different criteria, different projects has been taken. Suppose if it is a civil engineering, so they have constructed a very big dam. If the dam has been constructed, if they have planned for the dam, so they have to scheduling all the area, and the time construction constraint will be reduced and the cost also will be reduced. So that is what they have to plan. So for the civil oriented example here. And the second point for the critical path method, it allows an explicit estimates of costs in addition to time. Thus, it is suitable for establishing a trade-off for optimum balancing between schedule time and cost of the project. So, it is used for completing projects that involves activities of repetitive nature. So, there is a significant difference of PERT and CPM. Here I am just giving some little bit points. A network diagram helps to translate highly complex project into a set of simple and logical arranged activities, and therefore helps in the clarity of the thoughts and actions, and it helps in clear and unambiguous communication developing from top to bottom approach and vice versa among the people responsible for executing the project. And the second point is detailed analysis of network helps projects in charge to peep into the future, because difficulties and problems that can be reasonably expected to crop up during the course of execution can be foreseen well ahead of its actual execution. So, delays and holds ups during course of execution are minimized, and corrective actions can also be taken well in time. So, these are all the main significance of PERT and CPM. And the third point is isolate activities that control the project completion and therefore results in expeditious completion of the projects. And the fourth point helps in the division of responsibilities and therefore enhance effective coordination among different departments or agencies involved. Helps in timely allocation of resources to various activities in order to achieve optimal utilization of resources. In specifically, the fifth point is allocation of resources, very important to minimize the cost but maximize the allocations, maximize the resources. So, through the maximum resources, if you are reducing the, we are going to reducing the cost. So, that is what people who are working in a fast manner and completing the project immediately. So, the fifth point, it will help the major significant difference of PERT and CPM. And pages of project management, there is a three phases in the project management, and the first thing is a project planning phase, and the second is scheduling phase, and the third is project control phase. And the project planning phase, there are some little bit points are there. In order to visualize this sequencing or predecessor requirements of the activities, in a project, it is helpful to draw a network diagram. This is what in our syllabus, to draw a network diagram for the first initial process. And the second thing is, for this the following tips are adapted. Identify various activities, tasks or work elements to be performed in the project, that is develop a breakdown structure. And the second thing is, determine the requirement of resources such as men, materials, machines, money, etc. for carrying out activities listed above. And the third point is, assign a probability for each work package. The work packages corresponds to the smallest work efforts defined in a project and forms the set of elemental tasks that are the basis for planning, scheduling and controlling the project. So, I am just giving an example. Suppose for the starting of the concrete for the basement, so it is the first phase, we have to create the concrete work on the basement. So, through the basement we have to work for a different group of resources has been allocated, and specific period has been utilized for that particular resources and to complete the basement work. So, this is what the specific task has been assigned through this particular point. And fourth point, allocate resources to work packages. And the fifth point, estimate cost and time at various levels of project completion, and develop work performance criteria, and establish control channels for project personals. So, and there is a second point is scheduling basis. Once all work packages, that is our jobs like tasks, have been identified and given unique names or identifiers, scheduling the project, that is when each of the activities are required to be performed is taken up. It prepares an analysis estimate of the likelihood of the project to be completed on or before the specified time. The various steps involved during this phase are listed below. The first point is, identify all people who will responsible for each task, and the second point is, estimate the expected duration of each activity, taking into consideration the resources required for execution in the most economic manner. And the third point, specify the interrelationship, that is precedence of relationship among various activities. And there are the fourth point to the scheduling phase, develop a network diagram showing the sequential order interrelationship between various activities. For this, tips such as what is required to be done, why it is must be done, can it be dispensed with, how to carry out the job, and what must precede it, and what has to follow, what can be done concurrently may be followed. And the fifth point is, based on the time estimates, calculate the total project duration, identify the critical path and calculate the floats, and carry out resources smoothing or leveling, exercise for critical resources, taking into account the resources constraints if anything. So, these are all the scheduling base points. And the project control base is, project control refers to the evaluation of the actual progress against the plan. If significant differences are observed, then the scheduling and resources allocation decisions are changed in order to update and revise the uncompleted plan of the project. In other words, remedial, that is a modifying plan. Remedial or reallocation of resources, that is cost minimization measures, are adopted in such cases. So, I just giving here the model, the relationship with basis of project management. So, the first boxes represents the project planning. So, the whole project planning has been defined in the first box, and the second, project scheduling, is there. Through the project scheduling, we have to draw a network through the mathematical manner. So, the precedence network, so we have to draw a activity. Through the activity, we have to draw a network model. Through the network model, we have to find out the critical path method. Through the critical path method, we have to get the shortest duration and minimized cost. So, this was happened through the precedence network, through the Gantt chart. It is called Gantt chart, and through the Gantt, after the Gantt chart, we have to schedule the selection cost and then allocation of resources. So, everything has been to be implemented, and the periodic cost reports will be there, and finally we have to get the project control base, that actual task performance data has been there. Finally, we have to deviate from the plan. So, if there is a cost is high, or if it is the time will be high, so we have to reallocate the resources, and we have to draw a new network, and we have to deviate from the plan, from the first plan to second plan. This is what happening for this pages of project management. And through the mathematical manner we are going to talk about now, there are PERT and CPM network consists of two major components. The first component is events and the second component is activities. So, through the events, network diagram represents the project milestones such as the start or the completion of an activity, that is task. It is mentioned as nodes in mathematically, it mentioned as nodes in the network diagram. The events can be further classified into the following two categories. So, after the slides I am just giving some nodes and activities and events. So, the events can be further classified because the first network consists of two major components, that is events and activities, but the events classified into two events categories, that the first category is merge events and the another category is burst events. So, here I am just giving the diagram to get the events. So, here the merge event, an event which represents the joint completion of more than one activity is known as a merge event. So, here through the diagram, here we have here there is an event. The event has been taken place through some activities. It is a headed activities has been taken place, and the burst event, an event that has represent the initiation, that is beginning of more than one activity, is known as the burst event. So, here that is a burst event, that is a more than one event has been taken place here. And activities. So, the second thing is activities. So, activities in a network diagram represent a project operations or a task to be conducted. As such, each activity except dummy activities requires the resources and the task a certain amount of time for completion. An arrow is commonly used to represent. So, this is what the arrow has been commonly used for the represent an activity with its head indicating the directions of progress in the project. So, this is a head will be there. So, indications or directions of the progress in the project. Activities are identified by the numbers of their starting, that is style or initial event, and ending event. So, the ending event means it is a head or terminal. So, activities can be further classified into the following three categories. Events are two categories, and one is merge event, another one is burst event, but the activities categorized to three, and the first one is predecessor activity, the second one is successor activity, and the third one is dummy activity. So, what is meant by predecessor? The predecessor activity, an activity which must be completed before one or more other activities start is known as a predecessor activity. Through the diagram I can just show it to you. And the successor activity, an activity which starts immediately after one or more of other activities are completed, is known as a successor activity. So here there is a starting event, that is I, and the activity is been taken place to J, the completion event the second one. So here is I and the J will be the completion event. And tile of the arrow, so there is a node, already I have given the circle, every circle as a node. So that activity has been the tile of the arrow and tail of the preceding event. And through the activity we have a head of the arrow will be there through the node, and head of succeeding event is also there. So through the activity we have a dummy activity, so we have to mention like this, dotted arrows. It is not to the thickness arrow, so we have a we have mentioned as dummy activity, it's a dotted arrows. From here there is an activity, the node from the node we have to, suppose for example if it is A, and through this A, so we have an activity to B, and this is C, and from the B to C we have some other activity, so it was not mentioned, so we have to make it as it is a dummy activity. So two or more parallel activities in a project have same head and tail events. Two or more activities have same but not all of their immediate predecessor activities in common. So already I have given this example and show this diagram. So there is a starting event, there is a completion event, and the tail of the arrow and or preceding event, and the head of the arrow and the succeeding event, and there is a dummy activity for the two parallel activities for the two different nodes. So from the two different nodes we have a dummy activities. So the network shows the sequential relationship among activities using nodes and arrows. Network models use the following two types of precedence network to show precedence requirements of the activities in the project. There are two type of activities, that is AON and AOA. What is AON? So AON means activity on node, because already we have mentioned the node is there, and through the arrow is there. So the arrow and node is there. So through the node we have to take up the network and AON, that is activity on node. So activity on node means this type of precedence network, each node or circle represents a specific task, while the arc represents the ordering between tasks, and AON network diagrams place the activities within the nodes, and the arrows are used to indicate sequencing requirements. Generally, these diagrams have no particular starting and ending nodes for the whole project. The lack of dummy activities in these diagrams always make them easier to draw and interpret it. And AOA activity, that is AOA network, that is called activity on arrow. In this type of precedence network, at each end of the activity arrow is a node. These nodes represents in times or instance when the arrows itself represents the passage of time required for that activity to be performed. These diagrams have a single beginning node from which all activities with no predecessors may start. The diagram then works its way from the left to right, ending with a single ending node where all activities with no followers come together. Three important advantages of using AOA are as follows. Many computer programs are based on AOA network, and AOA diagrams can be superimposed on a time scale with the arrows drawn, the correct length to indicate the time requirement. AOA diagrams give a better sense of the flow of time throughout a project. Suppose for example, if it is a website, through the website, if any one website you can just go through there, and through the website there is a menu bar is there. Through the menu bar, so we have menu, through the menu we have a about us and academic. So suppose for example, if it is the educational institution website, so it is about us and academic part, and there is a administration part, and there is a research part. So these are all the menu. So through the menu we have a subtasks are there. Through the subtasks we have some pages. So through the pages, so there is a hierarchical structure has been taken place in this particular websites. So that is what the AOA diagrams has been utilized for this particular I mean the computer oriented projects. So here the rules for AOA network construction. So through the diagram I can just give it to you here. In this AOA network diagrams, the first one is activity A. The activity A means from one node to another node through the arrow, AOA network, and the second thing is B must follow A. B must follow A. So if it is B must follow means follow A means, so the A will be the first activity and B is the second activity, but B is followed by A. B must follow A, and the diagram will be represented here. B and C must follow A, and the first starting A, but B and C follow A, must follow A. So therefore there is a B node and there is a C node will be there. So the activity, the C activity and the B activity. C must follow A and B. C must follow A and B. So this is what here there is a starting activities are A and B, and followed A and B, the C will be there. C must follow A and B. This is the diagram. So this diagram, A and B is the starting place. So starting activity based on the C. And the fifth diagram is represented. C must follow A and D must follow A and B. But they have mentioned A and B, but we don't have any activity here. So in this type of activity, we are going to use the dummy activity. So we are going to use the dummy activity. There is a parallel activities are there. So from C must follow A and D must follow A and B. So they are mentioned A and B. If the problem has been taken place A and B, if you are drawing a dummy activity here. So through this dummy activity from the A to before the D and B activity through A. So this is what in the fifth representation. This is AOA network. But in AON network, the activity A means it is a encircled with A. That's all. And B must follow A means encircled A. So after that the activity has been taken place B. So and the third B and C must follow A. So AON network is represented look like this. So and C must follow A and B. So it is look like this. C is a AON network and followed by A and B. So this is represented in the fourth point, AON network. And the fifth one, through the AON network, it is C must follow A and D must follow A and B. So here there is a two activities has been taken place, A and B for D. So this is AON network. So there is a rules for AOA network and AON network constructions, because if it is the problem we are going to work out in upcoming hours, so definitely we have to follow these rules. That is what here the first point is, in network diagram, arrows represents activities and circles the events. The length of an arrow is of no significance. The second point is, each activity should be represented only by one arrow and must start and end in a circle called event. The tail of an activity represents the start and the head the completion of a work. The third point, the event numbered 1 denotes the start of the project and is called initial event. Already we were described this all these things in the figures, I mean the photos. All activities emerging or taking off from event 1 should not be preceded by any other activity or activities. An event carrying the highest number denotes the completion event. A network should have only one initial event and only one terminal event. The general rule for numbering the event is that the head event should always be numbered such that for each activity I comma j. So here it is I comma j, I is less than or equal to j. Sorry, not less than or equal to, I is less than j. Rules for AOO network constructions continued. The fifth point is an activity must be uniquely identified by its starting and completion of event, which implies that an event number should not get repeated or duplicated. Two activities should not be identified by the same completion event. Activities must be represented either by their symbols or by the corresponding ordered pair of starting completion events. The sixth point, the logical sequence or interrelationship between activities must follow these rules. An event cannot occur until all its incoming activities have been completed. An activity cannot start unless all the preceding activities on which it depends have been completed. Though a dummy activity does not consume either any resources of time. So there is a errors and dummies in network. So here there is a looping diagram will be there. So through the looping and dangling, there is a titles or looping and dangling. So the looping means it's a cycling. Looping and dangling are considered as faults in a network, therefore these must be avoided. As a case of endless loop in a network diagram, which is also known as looping, where activities A, B and C form a cycle. So A, B, C. So here it is A, here it is B and C. So there is a looping. Again it comes to the A. So it starts from A and going for B, and again it's coming to the A through the C. So the numbers has been displayed here through the event 1, 2, 3. So A, B, C are the activities. Again it's a looping. So in such case, due to precedence relationship, it appears from figure that every activity in looping or cycle is a predecessor or of itself. In this case, it is difficult to number 3 events associated with activity A, B and C, so as to satisfy rule 6 of constructing the network. So dangling means a case of disconnect activity. There is an activity A and B. So I am just giving just showing this drawing. A and B are there. So there is a C activity is called, it is a dangling. So a case of disconnect this activity before the completion of all activities, which is also known as a dangling, that is shown in the figure. In this case, activity C does not give any results. As per the rules of the network, the dangling may be avoided by adopting rules of constructing the network. And the dummy activity or redundant activity. So the following are the two cases in which the uses of dummy activity may help in drawing the network correctly as per the various rules. When the two or more parallel activities in a project have the same head and tail events, that is, two events are connected with more than one arrow. Already we have discussed in the through the theoretical, but here the through the diagram also. Here we have two different diagrams here. So the first diagram, it's the parallel activities from the activity A, and through the activity B and C it goes to the activity D. So So we are not having any dummy activities here, but in the second drawing there is a activity A and B and C, and through the C we have to follow some dummy activities D. So that from C to D we have a dummy activity. So when two chains of activities, so that is what the second point has mentioned, when two chains of activities have a common event yet are wholly or partially independent of each other, as shown in figure A, that is parallel activity. A dummy which is used in such a case establish proper logical relationship is also known as a logic dummy activity. Logic dummy activity. So here in figure A, there is a independent and I mean not figure A. So there is a figure A. If head event of C and D do not depend on the completion of activities A and B, then the network can be redrawn. As in figure B, uh, otherwise figure A must be followed, because here it is the independent events has been happened, and through the figure A it is the independent events has been happened. So through the parallel events are there, so the dummy activities will be happened here. So through this particular second diagram. So this is what the first problem we are going to see here, the example 1, and I am just giving a question. An assembly is to be made from two parts X and Y. Both parts must be turned on a lathe. Y must be polished, whereas X need not be polished. The sequence of activities together with their predecessors is given below. So there is a activities are there, and there is a descriptions also there, because already they have given, and predecessor activity will be there. So for activity A, B, C, D, E, F, G, H, and the description for the A, it is a open work order, and description B, get material for X. So if the description have not been given, so we have to make it our own project. So here they have given, so the open work order, B for get material for X, and C get material for Y, and D turn X on lathe, E turn Y on lathe, and F polish Y, and G assemble X and Y, and H pack. So that is the final conclusion of the packing. So first the material has been taken place, and finally they have to pack. So the predecessor activities are there. For the initial activity, it is here mentioned as dash. There is no place in the activity for the initial stage A. So there is no initial. So in the B there is a initial A. So and the third one is A, B, BC, E, D, F, G. So draw a network diagram of activities for this project. So based on this table, so we have to work out the network diagram. So here first we have to frame the table first. So as per the given problem, so here the activity is there and the predecessor activity is there. So first A, B, C, D, E, F, G, H are the activities, and the predecessor activity is also given. So through the predecessor activity, the initial A, which is slash, which means it is no beginning activity, and for the B it is A, for C it is A, for D it is B. So E it is B and C must be followed B and C, and F must be followed E, and G must be followed D and F, H must be followed G. So this is what the first process, and the second thing is we have to draw a network diagram for the project. So first initially we have to start up this circle. This is activity A will be there, and through the A, so we have to form the, through the A it is a starting point, and the second thing is the B must be followed A, B must be followed the A. So we have to draw the activity B, and again there is a C, C is also must be followed the activity A. So therefore from the A, B and C has been drawn, and after that the B, before the B, so it is the D must be followed the B. So after that D must be followed the D. So we have to draw a D activity, and then B and C is followed by the E, but B is goes to D and C is goes to E. That is right. But we are the B and C must follow E. So in this structure, in this network, so we have to draw a dummy network. So dummy activity. So from the B to C, so this network, so we have to draw a dotted activity through E. So that is what E must follow B and C. And E, the next activity is F. So through the F, it is must be followed from E. So that is what F has been happened. And there is a D and F. D and F must be followed. G must be followed D and F. G must be followed D and F. That is what G activity is there. And H activity is must be followed G. That is what the final conclusion of the final end. So from 1 to 8 we have activities. Through the activities we have dummy activities here. So from the predecessor activity we have to draw a network. So this is what the procedure to complete the network diagram.